We'll have our last talk that is virtual, and then we'll lead to the discussion for about an hour. So hopefully you've been keeping a lot of questions. So welcome Zhihong Liao from the National Meteorological Information Center in China. And he's going to talk about the analysis of global marine heat waves based on CMA Ocean Data Analysis System for SST datasets. Thank you.
Oh, okay. Thank you for introduction. I'm Zhihong Liao. I'm from CNA, and now I work in ICM with Christina and Emilio and Costino. Now my work is something about marine heat waves and using the CODAS dataset. As we all know, marine heat waves occurs because of ocean's warming. To learn about it, we are facing some issues, just like what is marine heat wave, why should we detect it, and how to detect, because it's a very key problem. This slide shows the key historical marine heat waves over the last 20 years. It had occurred in all areas of the global region, and in recent years, we can see the affected areas and become larger than before. To know about it, we should understand what is a marine heat wave. It always happens with prolonged appearance of unusual high SSTs in oceanic regions. When these events can last for days, weeks, or even months, and often covers large geographical areas. And the reason we detect it because it is insistent for protect our marine ecosystems and subsystem fishes and so on. And by monitoring it, we can better understand our natural systems and human communities. Now, we can use the temperature anomalies and find the durations and spatial returns of this anomaly. So we need a long series of high quality CSST products, and it's important for us to detect this marine heat wave. On the other hand, monitors marine heat wave is also a good text for SST's products. So this is the reasons why I do this work. Because the CODAS is a new CODAS products is a new product, and just we use in our systems. So let me take a short introduction about it. CODAS is the resolution of CODAS is 25 kilometers, and it's a daily product beginning from 1981. And the input data include in situ data for buoys and ship, and SST's retrieval data including infrared radiometers like AVHRs and microwave radiometers like AM SR2s, and some satellite data from Fengyun. And this slide shows the growth of CODAS-SST. We developed these products after quality checks, bias correction, and space and time and multi-scale analysis for this multi-source and data. And through independent buoys assessment in 1 year, we can see the average of the CODAS data. That is the right light, and it's between the OSTs and OSTIA. That is is close, quite close to the OST, as the result shows in the ever spurt and distributions and ever variations in the latitudes. The data set we used in that is the daily CODAS and the OST's data from 1982 to 2023, and we choose the mid-office SST trends as a reference, which is provided by Copernican marine surveys, and this as a strength is derived by the morning SSTs from 1983. This data and to 2021 estimates the resolution of 5 kilometers into 25 kilometers. Besides singular spot analyze methods is used to analyze the SST trends in the past 42 years, and 6 metrics about marine heat waves are estimated by the 2 products, like including CODAS and OST. And in this studies, the global oceans was divided into 5 regions, including Pacific Oceans, Atlantic Oceans, Indian Oceans, Arctic Oceans, and South Oceans. This is the result about the SST trends estimated by 3 products compare to the mid-office trends in the middle of the majors. The warning areas in CODAS results is related larger, and but the cooling area is quite small, especially in the North Atlantic Ocean, where in the OST results both the warning areas and cooling areas are quite small. The difference of the SST trend between these 3 products indicates the trends from CODAS related bigger in most of the oceans, especially in North Atlantic Ocean, where there are more negative views in OST results when compared to mid-office SST. This slide shows the difference of SST trends between the CODAS and OST. The result is quite small between these 2 products, and the average views is 0.05 degrees per decade. And the black points in the global area represent the trend is significantly different at the 5% level with significantly masked. The marine heat wave matrix of events and durations and total days from the orange CODAS and the original OST have create upward trends and during 1982 to 2023. Well, after the training, these metrics do not have a significant trends. This is the spur decrease of annual average marine heat waves assured that the result of mean intensities maximum intensities and calculated intensities and durations from CODAS and OST are quite similar, while the views of events in these B measures and total days from CODAS are quite smaller than from the OST. In this slide shows the categories. Since the total days of the in metal heat rate for CODAS and OSTs are different. The moderate days for CODAS is obviously less than less for the OST. Regionally, the Atlantic oceans and South oceans have more separate and extreme dates, which have related larger difference between CODAS and OST. This slide shows the mean intensity and extension of metal heat wave from detrained CODAS and detrained OST. And the results shows quite similar in Atlantic oceans and Pacific oceans, Indian oceans, and South Ocean. But in Arctic oceans, there are some difference with significant anomaly here. From the CODAS during the 1982 to 1986 have a larger loads means intensities and larger extensions in the in the Arctic Ocean and makes it's a difference in the global ocean. And this slide shows the 6 molecular traits from the traits CODAS and the traits OST. The matrix with largest difference in is the numbers of events, and the Arctic Ocean have the largest difference between the two products. This is the conclusions. In our studies, the sea surface temperature trends and the metrics are estimated by CODAS from 1918 to 2023, and is compared with OST. And the results indicate compared to the mid-office trends, the warning errors in CODAS results is related larger, and the coding errors is smaller. It passes in no Atlantic Ocean, while both the warning errors and coding errors in the OST's results are much smaller. Secondly, the results of mean intensity, maximum intensity, calculated intensity, and durations for CODAS and OSTs are quite similar. But the views of the events and the total days from the CODAS and are smaller than those from OST. So the meteorological days from CODAS is obviously less than those from OST. Last, the mean intensities and extensions of meteorological heat wave from CODAS and OST are quite close in Atlantic oceans and Pacific oceans and in Indian Ocean and South Ocean. But in the Arctic oceans, they have a significant anomalies from CODAS during 1982 to 1986. This is my presentation. Thank you.
Thank you very much, Hyun. So let's start with questions there for this talk, and then we can work our way back. Any questions online? I don't see anybody, so if somebody in the room has a question, Jorge? Wait, I can give you a microphone. Here, Jorge. Jorge. Wait. Here you go.
Thank you. Just a quick question. Thank you so much for that talk. In any of the analysis that you did you find a dependence of the marine heat waves and their intensity on resolution of the data set itself? Yeah, I'm sorry if I missed that. Thank you.
Oh, I will show you the data set. CODAS resolution is 25 kilometers and is is like the OST. The resolution is the same to the OST. Yeah.
Okay, thank you.
Another question in the room?
Yeah, maybe it's a question or comments, because your SAT trend is very strong, seems to me. So the question is, do you have any idea or expectation why? Because we also compare with, for example, ORSAT versus ERSAT and other product. Actually, ORSAT trend is quite strong. So in CODAS, if the trend is even stronger than that, so this means the trend is really strong. So I want to know whether you have any kind of speculation or reasoning.
Yes, we just in this works we just to compare the trends of two products here, but we not find out the reasons from so far, but we guess maybe we can find some information from the input data here, and maybe because we find two kinds of different. One is in the high latitudes, because the sea surface ice some region with ice here, and which makes maybe the methods in that regions is different, so makes the trends in the Arctic or South Ocean is different. And another side we think maybe is because the input data, and we used we not only used inference and data, we also used microwave data here, and in the early periods, and there are no microwave data. Maybe this is a reason, and some improve we should do it in our products.
Thank you. Another question? Well, I'm sure there was some questions for Joanna or Salvatore that maybe this is the moment to ask them. It's a race for the question.
Maybe I go first. I have a more general question about different SST product, and we from different more different satellites coming in. So a little bit about noise level, and when you have both in the the spatial resolution and the time frequency, because we know this cloud correction and different technology, and so perhaps for seasonal climatology or seasonal cycle or large scale, probably no much difference. But when you go to the look like a high frequency process, like a marine heat waves. So then the quality or the noise level of the data maybe become a factor, some other ask for resolution. Similar, we can ask for the, if you're in any way to test or have knowledge about this kind of noise level or uncertainty in the data can affect the statistics of the high frequency statistics. That's my question or comment.
Oh yes, I think this is a good direction to check out why the reasons that is different and makes larger trends in CODAS data. And we will do some works about this. Thank you for your suggestion. Thank you.
There was another question here, please.
This is sort of a general comment about heat waves in general, which is that the Hobday definition from the point of view perhaps of atmosphere ocean fluxes, that definition makes some perfect sense with regard to physics. But from the point of view of biology, different organisms that are affected by heat waves, the effect is different depending upon what the organism is. So humans have one effect, corn plants have a different effect, potatoes have yet a different effect. So what may kill humans may not affect potatoes, may affect corn. It all depends upon what the physiological limits of the particular organism happens to be. Now, we've done a bunch of experiments on heat waves using mesocosms, looking at effects on clams living in sand flats that are harvested commercially. And in Europe, in Northwest Spain, there are 3 species that are commonly harvested commercially, and the effects of heat waves differ dramatically among them. The Manila clam, which is grown worldwide, was completely unaffected by the heat waves, and our heat waves were only 4 days long. The 2 native species had amazing effects after very small heat wave impacts. We raised the temperature only for 3 hours a day for these organisms, and they completely resorbed their gonads after a 4-day exposure. And so here is a heat wave of a smaller duration than a Hobday heat wave, but it caused complete elimination of reproduction. And so this kind of raises the question, if one talks about heat waves, it's important to understand the context in which one is applying the definition. Because if one is applying it to agriculture, different crops have different thermal sensitivities. If we're applying it to humans, humans have a particular set of thermal sensitivities, and marine organisms have a wide range of thermal sensitivities. Corals at one end, which require high temperatures for some of their activities, but then there's a limit where they expel algae. And for other organisms that live in sediments or that are harvested commercially, those thermal limits are quite different. So it just raises the question, when we talk about heat waves, the Hobday definition doesn't necessarily tell us what was a heat wave from the point of view of an organism.
Thank you for that comment. I think it's a very good comment. There's a lot of debate in the biological realm exactly about that, but the definition has to start somewhere, right? Salvatore wants to reply, hopefully, to that.
Yes. First of all, I said I completely agree with the fact that heat wave, the impact of heat wave is very important over the environment and over the species. Of course, depends not only because species doesn't care about anomaly. For instance, about temperature, about rate of increase. For instance, if we have an increase of temperature, a couple of degrees in a few days, as happened in the Mediterranean Sea, it's a fact. If we're going very slow is another one. And what we found, for instance, in the sea is a strong impact of the marine heat wave over the spring bloom. Okay, I'm not talking about higher level species, but even if you start from phytoplankton and chlorophyll spring bloom during spring, people found that the presence of marine heat wave inhibit the bloom, and then I can imagine, even if I'm not a biologist, that this can have an effect over all the level or trophic level going up. And of course, species have nothing to do against a very strong increase of temperature. Human can. We are conditioned. They haven't, for instance.
Thank you. And I would like to add a comment there that I think when this definition was done, I don't think we had the gigantic marine heat waves that we have now. I mean, we talk about a definition of 5 days, and then we experienced heat waves that lasted months or even years. So that kind of became irrelevant for some of the studies that we make.
In fact, the definition of marine heat wave had to be reformulated very, very carefully. For instance, the paper I cited, they was very interested to environment near the coast, and they said that we need a very, very clear definition of marine heat wave. And this is, I think, the next step they have to do. There is not one definition which is correct, another one which is wrong. Depending on what are looking for, depending from the framework where are you doing your study. So this is central point. And if the marine heat wave doesn't stay for a few days or a few months, but years, and of course, or if the temperature go up and then stay, can we still talk about wave?
Thank you. Somebody has a further comment on that? I'll encourage people online. And also, Christina and Christopher are still online too, if you want to ask a question for them. There's a question here in the room.
Yeah, thank you. So this is briefly for Chris. Very nice presentation, Chris. Thank you. Did you, when you calculated your trends, do you take into account the measurement uncertainties in the data set? And related to that, have you changed your thoughts as to how uncertainties evolve depending on the temporal and scales analysis of what you do? And my second question was going to be related to the spatial sampling, if you use consistent spatial sampling. And I wondered if you looked to see whether the clear sky numbers have changed over time, given your comment on the aerosol changes.
Good questions, Gary. Thank you. Any false trend in the CCI data will be wrapped into the linear term. The parameter for uncertainty on the fits is pretty negligible, and therefore that instrumental uncertainty is the uncertainty in the linear trend, more or less. And as for the second part on this, I didn't quite understand what you're asking in your second question.
When you calculate your average between 60-60, do you use consistent sampling over every?
Oh, sorry, yes, it's calculated from the level 4 product.
Ah, okay, it's a level 4.
It's calculated from the level 4, area weighted, of course, so that's consistent with area. Okay. And yes, if you look into the series data a little bit carefully, it's the reflected solar that has changed in a big way over the last decade compared to before. So it is a cloud change, a cloud-driven change to create that change in the Earth energy imbalance, mostly over the oceans.
The data. Can you see that in the CCI data? The number of measurements.
We haven't yet looked, but it has occurred to us that we should be counting how many clear sky observations we're getting to look for it, but we haven't actually had the time to look.
Okay. No, very good. Thank you.
Thank you. Christina online has a question. Go ahead.
Hi, this was another question to Chris as well. So thank you for the presentation. I found it really interesting. And indeed, we are trying to understand these kind of changes in 2016. I mean, for me, it's really obvious. I'm not sure if I have understood properly the presentation, so that's I ask. I'm sorry if I didn't. Are you assuming that the Earth energy imbalance is hitting all the mixed layer depth or just a part? That's what I didn't understand. Yes. Because somehow I think that what it seems is that it's just hitting the more shallower layer, that the stratification is increasing.
What we've assumed is that the fraction of the Earth energy imbalance that goes into the mixed layer is constant for the purpose of that calculation, and in that situation, the trend is basically proportional to the Earth energy imbalance that you see, okay. Of course. There's a lot more heat going into the ocean than just into the mixed layer, though. In the long run, 90% of that Earth energy imbalance is going into the oceans, but only 25% of it is needed to explain the mixed layer trend. Because the mixed layer is only 63 meters deep, even sunlight in some places can get deeper than that, and therefore there is a large fraction of the EEI is going in below the mixed layer and is mixed down from the mixed layer as well.
Okay, thanks.
Thank you, Christopher. There's another question in the room, and if I can ask if you guys can introduce yourselves and where are you from. I know that most of you know each other, but for the online people and for the new ones here, it will be great to get to know everybody.
Yeah, okay. My name is Bo Ying. I'm working in NOAA NCI. So my question to Chris is kind of one or two. So for giving Earth energy imbalance at the top of the atmosphere, right? So how much actually this imbalance can apply to the ocean surface? I mean, how much may be absorbed by atmosphere or so that's
yeah. There's advection going on. There are vertical processes going on. There's a lot going on. So what I'm assuming is that if we look at a long enough time scale, those processes are behaving similarly, and ultimately a certain fraction of the Earth energy imbalance goes into the mixed layer. Now, it may be that some of the unexplained increase in temperature is because that assumption is wrong. It may be that for some reason, dynamically over the past El Nino cycle, a greater fraction of the Earth energy imbalance has gone into the mixed layer, and perhaps less into the deep ocean. Like Christina said, it could be that there's a stratification effect going on, and that's currently the sort of thing we're looking into using three-dimensional ocean data, not just the SST.
Okay, so the question even more, one more step forward is what causes this Earth energy imbalance? Do we have any kind of suggestions?
Well, as I mentioned, there has been less cloud, particularly in the northern hemisphere over the oceans, over this past El Nino cycle than before, and that's evident in the series data. If you look at the components, which I didn't show you, if you look at the components of the radiative flux at the top of the atmosphere, it's the reflected solar that's had the big change. Now, where that comes from, that could be related to an aerosol-related effect, because of course aerosols in the atmosphere do seed the clouds, but the patterns don't have an obvious aerosol-driven explanation, and so that requires a bit more work. If it's shipping aerosol, you'd expect the big effect on the clouds to be right along the ship tracks, and they're sort of vaguely in the right area, but it's not really that obvious that they're connected to shipping. And if it's the deindustrialization on the eastern seaboards of the big continents, again, you'd expect that to have a particular spatial pattern, and it's not obvious. But then, of course, clouds move, the atmosphere moves. Maybe with more analysis, it could be traced back to an aerosol effect. Certainly, some people, including Jim Hansen, for example, are very worried that this is a permanent change because of us cleaning up the aerosol problem. I mean, aerosol is a good thing to clean up because it's an air quality issue, but he's very concerned that it's causing this long-term increase in Earth energy imbalance. but I don't think there's definitive evidence as to whether that's really the mechanism yet.
Thank you, Christopher. There's another question. Salvatore, go ahead.
I'm Salvatore Marula. I introduced myself already. I have a comment for Chris because he said that part of consider the mixed layer depth, part of the radiation can also penetrate below the mixed layer depth. And it would be interesting to compute the fraction that remain in the mixed layer and to contribute to the warming. And consider that in the present situation, people are starting to talk about ocean desertification, which means more transparency. This should be work in the other sense, limiting the warming in the upper ocean, but more heat in the deep.
Yes. Yes, I hadn't heard that phrase before, but you're right. It would have the opposite effect. I think it's really, as I say, the EEI has been driven by the clouds, the change in clouds, and that's the primary effect. And how much goes into the mixed layer compared to deeper is second order compared to that, I think, but still in the long run going to be important.
Thank you. Any other question in the room or online? While you warm up, I do have a question for all the speakers, but people in the room too, especially those that produce data, SST data in the long term. I'm really a user of SST, and kind of following a question that Jorge had yesterday about, like, we ask all the time, what SST product do I use? And here in these talks and other meetings, I'm starting to think, like, maybe I just need to use an ensemble like we do climate models, right? I mean, they are used for global trends or global analysis, but if I want a particular region, maybe I just take different data sets and do an ensemble or show the ensemble of difference. The differences are small from the user perspective, especially for ecology, but maybe not that trivial when we come to talk to terms of trends or marine heat waves. So I would like to hear your thoughts about that, like combining those data sets or showing them as an ensemble. What do you guys think? Jorge.
Thank you, Marisol. Yeah, just following up on that, I think one thing, from these talks is that we really need to, even though they might not be officially a GRIST product, they still might be a very good product for users to implement. So I recommend that we start looking at documenting some of these new products. I mean, for example, the sea surface temperature and sea ice temperature product. I think that would be extremely useful and could lead to some breakthroughs in some areas. So I would really recommend that somehow we find the right way to document these and point users in those directions. Thank you. Sorry.
Yeah. You want me to pass you the microphone?
It's just to answer to your question. There used to be an ensemble product which was called the Gimpy, which was maintained by UKMet and which was made over a series of different level 4 products. So maybe this is something we have to revive somehow.
Thank you.
Just to add to that, it was interesting. The variance in validation of the median of the Gimpy, the GRIST multi-product ensemble, was always better than its component models, and that was always quite an impressive feature of them. So there's definitely some merit in looking at an ensemble for as a comparison point for our different analyses, because the median of the ensemble is often quite a good product. But I think your point, which you alluded to, about some it depends what your application is. If you're really looking at trends, you want to make sure you choose an SST product that is as stable as possible. And as we commented earlier, some of them are not as stable and have unrealistic trends compared to others. So in that scenario, then you just want to try to establish which is best for your application. So it depends on your use.
Christina, seems like you want to follow up on that.
Yeah, I mean, it was going to be my same point. It just depends on the application you're going to use. I mean, if you're interested in study climate, maybe you will need other issues that if you are more interested in the dynamical, for instance, me, I'm interested in retrieving the dynamicals from SST. My needs are going to be different, and that was related with the fidelity testing that we didn't continue, but it's different. I mean, the metrics are going to be different. Yeah, that's my point.
Indeed. Chongjon, I think your hand is raised. Please go ahead.
Hi. Sorry. Hi, Chongyon from Matt's office. I just heard the name Gimpy, so I thought I might just chip in a little bit about that. So, yeah, so we used to give out the Gimpy products to publicly, but because Brexit and then the change of Copernicus contract, so at the moment it's not going anywhere. We're still producing it, but it's just not being accessible. So in terms of application, I think just to mention the Gimpy products, it's coarser than a lot of the L4 products we use to produce ensemble. It's a quarter degree. So some of the products we use to produce it is a 0.01. So depending on your application, whether or not that's a it's a good thing to do just to use a coarser ensemble. And just on that, I'm going to have a talk tomorrow about Gimpy in more detail, so that I could answer a lot of Gimpy related questions then. But there is a slight hope that we can get it available again to public, because I think from January next year we're going to start to renegotiate rejoining Copernicus. So there's a hope that they might be available again through Copernicus, or we could make it through other channels. So I have a race to add Gimpy to the kind of UK-based sort of dissemination service called UK MCAS. At the moment, that's not on the list, but if there's a lot of user requests, we can always keep raising the priority of that. So I really hope one day we can make it again publicly available. Thank you.
You have my vote there, Chongyun.
Yeah.
Yes, because the user, and there's different users, of course, but it's very difficult to sometimes be aware of all the details of the different data sets, right? Which one is stable or not. You tend to use one and get married to that one because you kind of understand that and that's it. But it seems that that it will benefit from knowing others, and I would love that kind of product. Okay, hopefully there was enough time for thinking of another question. Yes, please, in the room.
Veronica Lance, NOAA Coastwatch, and NOAA SST. To the discussion about which SST to use in NOAA Coastwatch, we're sort of the link between the upstream providers and the downstream users, trying to connect those. And we are spending a lot of our thoughts and not having maybe good results just yet, but we're working on it. What kinds of questions or what kind of shopping, taking an analogy of shopping for, I was saying before, a prom dress or shoes, whatever you want to shop for, where you put in your parameters and it comes out over here. And I think with more and more, the chat bot kind of thing, the more tools that we have available that can help sift through people's choices that are out there, and then line up the products. I mean, that's like my vision, that we have some sort of interactive questionnaire for people that that you can slide. You want sparkles on your dress or ankle length, or what region are you interested? What's the time period that you're interested in? Go through all this. So those are some easy, obvious answers that you don't need fancy techniques to do, but there's probably more because your application is going to be pretty unique to compared to the next person's. And so really thinking about what are those questions and how do we, and then you have to work on what are the metadata to be able to pull out all that stuff to choose that. So it's an excellent discussion, and we're thinking about it. I don't have a good answer right now, but I hope we can make some progress there. Thanks.
Thank you. No, I think it's very encouraging to hear that those products exist and they're still thinking about it. From the user perspective, it's amazing. Another question online. It's too late or too early for some of you. Yes, there's another one here in the room. Andy.
I don't know how close we are to some sort of break, but and I don't know if this really answers the question, but when somebody says which products should we use, there is amongst those of us that make SSTs, particularly the people that make level 2, level 3, and level 4 products. The answer is, well, the best one, because we know that there is kind of an optimal way of doing it, and we're trying to work our way towards it. So no one ever said, oh no, I don't need climate quality. If you give me climate quality, it's going to be bad. So everybody wants consistent. Some people may want very high resolution. Some people are happy with 1/4 degree, but what you really want is that those different products are consistent. I mean, for example, today we have a plethora of analyses running at 1/20th degree, or maybe even down to sort of the 1 kilometer level. We'll never do that back in the 80s because we just don't have the data to make such analysis. We've got AVHR, GAC, and it's got its various issues. But what we do want is that on the scales that we can compare them, that they are consistent, which is not easy, but it's what needs to be done essentially. So yeah, there are not many products that are fully consistent end to end in terms of not just the level 4 processing, but the data that goes into it. I mean, it might even be that the CCI is the only one that's actually fully consistent in terms of the level 2 processing and also the level 4 processing. I mean, does anybody know of any other product that's like that? Back to 1982, and is it a level 4 product? Yeah. So nothing back in 1980.
Back to 1980 now,
my
Andy.
point, but so what?
Back to 1980 now.
Well, exactly. Oh, okay, right. Because you've got stuff from the 4-channel AVHRs now.
06, yeah.
Yeah. Okay. Okay. I could have an offline question. What's your take on the 3.7 micron noise? Sorry, that's a bit of a technical question, but how much of an impact is it having? What are you doing?
Well, I would say that those very early years when we were relying on the even numbered NOAAs are works in progress.
Right. Okay.
We made a start. I mean, they are difficult to get good SST at.
Okay.
Owen can tell you more.
Right. Okay.
Thank you. We have another.
Yeah, it's also maybe a question. You look from Fisher Ocean, Canada. I'm purely a user for the SAT product rather. So it's a thing about, if we do require very high resolution, both in space and time, SAT product to, let's see, less than a kilometer to look at the coast, near shore waters, France, or the, very near coast upwelling. And I don't think all this satellite data, we do have this different way to interpolation, and so maybe not still satisfy the need for this kind of high resolution. So I wonder, the data simulative ocean models or a couple of simulation models, those kind of product can give the highest resolution in both space time needed for development application. So am I too far off the mark?
This might be answered by Trishna in the room. I don't know.
Does anybody want to comment? Go ahead.
Emmanuel Autrette from Ifremer. Just a quick answer. We have heard a couple of words of the upcoming mission, such as Trishna, which will have 60-meter resolution with a revisit period of 3 or 4 days. So in time, it's not very high resolution, but it's better than, for example, Landsat. And so Trishna will be launched in 2026. Then in 2028, SBG from NASA will be launched with similar characteristics. And in 2029, the LSTM missions from ESA will be launched with 50 meters resolution. So in 2029, from 2029, you will have 3 missions with so a revisit of about 2 days and a special resolution of about 50, 60 meters in the coastal zones. So 100 kilometers of the coast, and all semi-enclosed and enclosed seas will be covered too. But yeah, for the moment, you can also try to use the EcoStress data from the EcoStress mission. So it's an instrument on the International Space Station. And I think there is a poster from David Wethe today. Yes. Okay, I think for very high resolution, I think we have to wait for future missions.
Thank you. Sorry, there's a follow-up question here.
My question is, can this kind of instrument with a very high spatial resolution have a sensitivity to temperature enough to appreciate very small gradients? Or maybe they can also variation like 2 or 3 tenths of a degree? EcoStress, for instance.
I think for EcoStress, maybe David can answer. For Trishna, I don't have in mind the numbers exactly, but the radiometric performance that are expected should allow to observe weak gradients. But we can talk maybe later.
Yeah, EcoStress has about a 70-meter resolution. It has, depending upon which period of record you're talking about, between 2018 and 2022, it had 3 spectral channels, 8.5, 10 point, or 8.78, 10.49, and 12.09 microns. It actually has 2 other channels that had to be turned off because of data transmission limitations, but now since October 2022, those channels are now back on. So it has enough spectral resolution at this point that cloud detection is easier, and potentially the algorithm that's used for temperature retrieval is also better. The algorithm used globally over water and over land is the same in ecostress. It's always a temperature emissivity separation algorithm. And with only 3 channels available during the period 2018 to 2022, the ability to resolve the emissivity is limited, and especially over water, the emissivities are always way too low. And so this results in some problems with the temperature retrievals from ecostress. In the long-term record, there's about a 1 degree bias cold, and there's been a radiance adjustment that's been made by regression against in situ observations that has corrected part of that. But so there's some issues with ecostress. It's an experimental instrument. It is kind of proof of concept for high resolution. It has a high NEDT, so there's quite a lot of uncertainty in all of the retrieval channels. So all of the radiances have quite a lot of noise, both temporal noise and also spatial noise. And so there are strange artifacts, there are stripes, there are checkerboard patterns after you do geolocation. So there's some issues, but as a proof of concept, it's great. And as a test bed for figuring out how to get data from a high resolution instrument, all of the future instruments are going to have a high NEDT because the pixel sizes are small. All of them are push whisk instruments, so they have a focal plane arranged in the direction of travel of the satellite, and then they have a mirror that sweeps cross track. And the length of time allowed to acquire individual pixels on that mirror rotation is very short. And so there is not enough time to get an extremely good measurement of radiance at any individual pixel. And so that's just a limitation of the type of instrument. If you want high spatial resolution, you're going to have high noise. And so it's something that we're all going to have to live with in these high resolution instruments. So there are trade-offs. If you want high spatial resolution, you get radiometric noise. At lower spatial resolutions, you have less radiometric noise because you have longer integration times. So there are trade-offs in all of this. We gain spatially, but we lose in terms of the standard deviation of the radiances that go into our retrievals. And that's something that we're going to have to develop algorithms to deal with that. Pras. Sorry. You get both nadir and slant in the well, no, it's a single view. It's not like SLSTR. It's so at the center of the mirror swath, it's pretty much nadir, and then as you get farther away from as the mirror continues, so it starts at a something like 30-degree angle, and then it passes to looking straight down at nadir, and then it goes back up. So the edges are bigger pixels and steeper angles.
Can you use the microphone?
It's looking pretty much straight down.
No, well, we cannot hear you over here or online. Thank you. Christopher, you have your hand raised for a while. Are you still there?
Thank you. I have a question for Salvatore. At the onset of that large marine heat wave in the Mediterranean, I think you said in 2022, was extremely rapid and widespread. What was the meteorological cause behind that rapid onset?
Salvatore, that was for you specifically.
The question, please.
Salvatore, okay, you want me to repeat the question?
I lost I will not capture your question. Can you repeat?
Sure. I was asking about the onset of that very the very rapid onset of the marine heat wave in 2022. I think it was 2022.
Yes, it is.
Which was across such a wide area and very intense and quick. And I wondered what the conditions were that caused that rapidity of onset.
Oh yes, yeah. No, the onset was very rapid. It's until a few days, 2 degrees increase, and the meteorological situation was exactly the African anticyclone, which was that invaded the Mediterranean Sea, and then there was, of course, typical calm wind and a lot of insolation that started just at the time. So it produced this very fast and more or less uniformly distributed over the Mediterranean Sea, but the stronger effect was in the Northwest Med. 4 degrees of increase.
Thank you.
Another question? Well, seems like we are all ready for some mingling and posters. Thank you very much to all the speakers.